Hi guys, my name is Patrick, but you can call me 26, and what we're going to do today is another question. And the question in question is going to be median data stream, right? So the median is the middle value of an ordered list. If the size of the list is even, there is no median value, so you get the median by getting the mean of the two middle values. So we're supposed to implement a median finder class, and you're given the methods. You're supposed to create the median. One will create the median object, and then we're going to add the number, which is going to be add an integer from the data stream to the data structure, and then find median function is going to return the median of all elements found so far. So what they want us to do is we need to maintain essentially an ordered list that we can call and find the median at any time. So in order to do that, we should keep the list arranged, right? It would be a lot easier to when you want to call and find the median if the list is already arranged. So every time we enter a new number, because it's an add number function, we want to ensure that we're entering the number into an ordered list, right? So we enter a number into an ordered list, and afterwards we get the median by getting either the middle value if it's even, the middle value if it's odd, and the middle two values if they're even, then getting the mean of that. So basically that. And for that we would use binary search. So if you're doing this question, you should be comfortable with binary search. So let's get to it. So here we have our array of numbers that you're going to use to convert into a stream, and this is going to be the object that we create, right? So let's get to it. And the first thing we're going to call add number. So we're going to take a number and insert it. And when you're inserting a number the first time, we're going to insert it at the front or anywhere in the on the object, because after all the object is empty, right? So you insert it at, maybe you could append it, like if you use an array. We're going to use an array, so you append it in the array, right? Then afterwards, getting the median is pretty straightforward because we only have one number, so you just get the middle of the one element. It's odd, so the median is 2. Right, and then we call add number, and we add the next number, which is going to be 9, right? So in such a situation, getting the median, because it's an even set of even number of elements, that's going to be 9 plus 2 divided by 2, which is going to give us 5.5. And we call add number again, and this one is going to put 5, and now we slide 9 up 1, and then put 5 in the middle, and now getting the median is just getting the middle number, which is going to be that, right? Then we continue, we call add number, and now we add the number 3. So we slide 5 and 9 up, slide in 3, and then getting the median would be 3 plus 5 divided by 2, which is going to give us 4, right? That's the median. And we do the same, we call add number, and now we have, we're adding the number 1, so we slide everything up, slide in 1 at the beginning, and when we slide in 1 at the beginning, the median is going to be the middle number, which is going to be, in this case, 3, because there are 5 elements. And now we add the number 7. When we call add number, we call 7, so we move 9 up a spot, slide in 7, and now getting the median is going to be the median of 2, because it's 6 elements, so that's going to be 3 plus 5 divided by 2, which is going to give us 4. The median is 4 now, right? And then we call add number, and we slide in 4 by moving 5, 7, 9 up, slide in 4, and now when you call the median is just going to be the middle number, which is still going to be 4, right? So that's how you solve the question. You use binary search to add the element into the stream, depending on where it is, so that you can keep it ordered. And then when you want to get the median, if it's even, get the mean of the two middle elements. If it's odd, just return the middle element, right? So that's basically how you get the median. Let's get to it. So the very first thing we need is going to be an array where we're going to put our numbers, right? So we have var nums and not buns, but nums. And nums is going to be an array of integers. And when we start off our array, we just want to come here and say self.nums, and this is going to be an empty array, right? So we're going to initialize it to being empty. So initialize an empty array, and now we have add num, right? Add num, first we're going to check if the array is empty, we should just append the number, right? So we come here and we say if nums dot is empty, and remember in Swift it's always faster to check is empty rather than check the count, right? So this is the fastest way to check the emptiness of an array, right? So we just say, in this case, nums dot append and the element we want to append is going to be the number, right? And after this, we just want to return from this, right? So come here, return. That's done. Now the next one is going to be we need to do the binary search. So we come here to say var start, and start is just going to be at the left, then end is going to be at the other end, right? So we say while start is less than or equal to end, we want to get the mid, and we say the mid var mid, and mid is just going to be start plus end minus start divide by 2, right? That's going to be our midpoint, and we check if the number we're currently looking at is greater than the number in the middle. We need to move our start, right? Come here and we say start is going to be to the right of that, of the mid. So we say start is going to be mid plus 1. Else, if num is less than num's mid, we need to move the right pointer, which is in this case is end. So we say end is going to be mid minus 1. Else, that means it's bang on the money, right? Else, and this should be mid minus 1. Swift is finicky about space. Else, and what we should do is just set the start. We've gotten where we should put the element, right? So we say start is going to be mid, and we're just going to break, right? So we do that, and now what we want to do in such a situation is we would like to insert that number into the position where the start ended, where the start left, right? Because that's the point where we're supposed to insert it. Because we have looked for all the places that you're supposed to insert it, and we get to the point of the number that it is just greater than, right? So this is the point where we want to start it, to insert the number that you're currently looking at. So for that, we just come in and we say nums dot insert, and what we want to insert is num, and we want to insert it at the start position so that we can move the other elements because we have found where we want to put it, right? So that is done. Now the next thing is to find the median, and this is pretty straightforward. So the first thing to do is get the count. So we say let count, and count is just going to be nums dot count, like so. Then we say var median. Median is going to be a double, and this is going to be 0, like so. And we say if count dot is multiple of 2, right? And now instead of checking whether if you divide it is divisible, if you divide it and it's divisible by maybe 2, if it's directly divisible by 2, and then returning the answer, what you could do is you could use is multiple of, which works exactly the same, right? So this will return true if it's a multiple of 2. If it is a multiple of 2, the median can be gotten by, and this is just going to be nums, and here we're going to get the count divide by 2, and to it we add nums, and here we're going to say we could come here and we say count minus 1, and we divide this by 2, count minus 1, and we're going to divide this by 2, and then we're going to get everything, wrap everything and divide it by 2, right? Come here, do this, and of course it's complaining because this should be a double, so we get the double, and for that just come here and divide this by 2, right? So get that like so and divide it by 2, and that's going to be what our median is. Else that means that there's a median, just return the median. Median is going to be double, and what we want is going to be the nums, and we just want the count. If it's even, just get if it's odd, just get the number in the middle, right? And at the end of all this, what you're supposed to do is you're supposed to return the count, return the median, right? So that's how you would find the median. Let's put it through its spaces. Let's run things. So come here, hit run, and see what that looks like. That's accepted. And if we actually submit this, let's submit it and see it. And it is submitted bang in the middle, right? So let's talk about the time complexity and the space complexity. Let's talk about time complexity. The time complexity is going to be O of n, and I know you might be wondering, why is the time complexity O of n when we primarily use binary search? Well, the add number function, consider this, right? We're trying to add the number 0 to our array currently as it is, right? For us to do that, we'll have to move everything up n spaces so that we can add the number at the beginning. That's the worst case scenario, where we have to add at the end, right? At the beginning. So when you're adding at the beginning, we have to move everything up one space. So that would be n steps, right? So in our worst case scenario, add num, aside from binary search, which is going to be log n, we are going to do n steps, right? So we're going to move everything n steps. So it's going to be worst case scenario, and add num is going to be O of n, right? And now when it comes to the median in a worst case scenario is where we're dealing with an even number of elements in the array. We're going to add at a maximum 2 elements from the array, right? And divide by 2, right? So that's going to be worst case scenario. If it's odd, it's just fetching, right? So if it's odd, we're just fetching. So in such a situation, regardless of how big the array is, we're just going to be doing a constant operation, right? Adding 2 numbers and dividing by 2, or just returning one particular element, right? So that's going to be O of 1. It doesn't scale with the increase in the number of elements in the array, right? So the time complexity for this is going to be O of n. For the space complexity, it's also going to be O of n, because we do create an array whose size is going to be equal to the number of elements in the particular array that you're trying to put, right? We're trying to create, right? So that if you have many elements, you're going to have a much bigger array. So the space complexity is going to be O of n.